I started the recording, so let's go ahead and start our little lecture for today, week 11. First off, are there any questions, concerns, things I need to address about the midterm? I'll, if needed, I'll spend a few minutes addressing any immediate concerns. Go ahead, Vera. Raise your hand, Vera. I don't hear you.
Oh, sorry about that. That was my
Okay.
bad. I was just saying I had a question about number three. I have a few of them, but that's the first one.
Right. I'm gonna pull it over
Thank you.
in a second.
Mhm.
I do want to say that there wasn't really, there literally wasn't one question consistently that everyone missed, so it was it was quite across the spectrum, so let me just open it up here, give me a second. All right. Questions. All right, three
Yes.
in the default
So,
order. Go ahead.
yeah. Oh, go for it.
No, you go for it.
Okay. I was just so it says, yeah, the order of precedence, which operator would be evaluated first. This one to me felt like more of a multiple select than a multiple choice because it seemed like there were two correct answers from what I understood. If you scroll down, subtractions and additions with PEMDAS would be equivalent, as well as multiplications and divisions.
Uh, no.
No?
That's incorrect. It's always multiplications and divisions. There's always
What do you,
evaluated first. Um, so
okay,
if you had a calculations with addition and multiplication, that's still going to be um, evaluated after if there is
but
another.
there's,
Yeah.
but there's a subtraction and an addition above this one, isn't there? So that's what I'm talking about. That would be equivalent to itself,
No,
right? Like it would be from left to right.
no. So
No?
let's take a look at this.
Okay.
You have something like three, oops, three plus, and let me make sure, plus four
Mhm.
times seven, seven divided by eight. Oops, eight. Which which would be evaluated first? Not the three
The,
plus four.
no, I
Well,
know.
we can even put minus five without any parentheses. How is that evaluated?
I mean, the multiplication or would be first, but my point is that subtraction and addition, if you had three plus four minus five, it would be left to right.
Oh,
Vera, I think that your confusion might be that it's not comparing the pairs in the different answers. The
Um,
question is overall from all of the options, which
which one
one
would
would
come
come
first?
first? Yeah,
that
so addition and subtraction weren't being compared to each other, I
yes,
think.
that's correct, Mackenzie. So it's not
Okay.
about like if you had a a calculation like this, it would
Mhm.
be left to right. But if you had all of those operators or in one calculation, it's always going to be division and multiplication first.
Right, I can understand that.
Yeah.
Would you mind scrolling up to the question again? Just maybe I misunderstood in the default, which operator? Okay. Yeah, I
So,
guess I understood the question as saying like out of these options, like
oh,
which one of these is true, I guess.
yeah. So we did talk about the default order of precedent and it had specific operators in order. So that's what this question is referring to.
Hmm. Okay, cool. Thank
Okay.
you for the clarification. And
Not,
thank you, whoever chimed in as well. That was helpful.
that was Mackenzie.
Thanks for canceling. The next one was question 12.
I have to count. So which one? Do you remember which
Yeah,
one?
it had to do with rounding, like the dates, rounding the dates. I think it
This
was that one. Yeah. So I can understand, I guess like it was supposed to be the next year. That was the correct answer. But when I had gone through the material when I was like studying for this, the examples shown showed that it always rounded the date down. So I kind of was confused on
no,
exactly what was supposed to happen.
um, so if it's rounding to the year, so it's just you want to think of this as rounding. So um, well, let's take a look at the responses, see if we better. So it's rounding to the year is July, which is um, essentially halfway through the
Rounding,
year '03, right?
right.
So
My, mhm.
go ahead.
I was just, I understand that it should round up, but my point is that the dates in the lecture, there was one example where it was like a November and it rounded down to the current year, like the results showed. And I didn't actually check it, which is probably on me, but like the example shown in the lecture showed it that it always rounded down regardless of
Okay.
where the month was in the year.
Uh, well, it really depends on what well, no, the year works the same as basically if you're rounding to the year unless it's doing something different. If it's past June 1 or May 31st, whatever, then it's going to round up, just like a number. It's the same principle.
Mhm.
I'm not sure, you would have to show me maybe offline what what example was rounding down
I
to the year.
It's in, I mean, I can send you the link if it's helpful. It's in lecture 4, page 51.
Or don't be that person.
I'm sorry, I just, that's who I am. But
Okay.
it's okay. We don't have to go over it now, but that's what I was referring
I
to.
Vera, I'll take a look at it.
Okay.
Could possibly that it's listed wrong. That's not a problem. And if it
Mhm.
is, yes, things like that, I will review and let you know. Okay,
Okay.
just,
Thank
yeah,
you.
and send me that. Yeah, you said it was in lecture 4. Yeah, I'll remember.
Yeah. Thank
And
you.
let me make a note of it, so get it in my trusty little absent-minded professor book, notebook that I have here. Question 12, lecture 4. You said page 51 or slide 51?
Yes.
All right,
Although, yeah.
okay,
So,
got it.
yep. And then the last one was just question 50. I wasn't familiar with the terminology and I wasn't sure if we had covered it in
Well,
class.
we didn't really cover, well, it was in the lecture. I didn't really stress it that much. I glossed right over it. Um,
Like, mm, like the equijoin, I think it
yeah,
was. Yeah. So,
it was in the material, in the resources.
mm, okay.
Um, yeah, I didn't really cover it. It's not a big factor as far as joins, but um, it's that one, yeah. I was considering leaving that one out or changing it, but I did see it in the resources.
Okay.
So
I
that's
must
why
have
I
just
left it.
missed it.
And
Okay.
that's why I left it in there. Okay,
Thank you.
you're welcome, Vera. Anyone else? Questions about the midterm?
I do have one question.
Go ahead.
Uh, is there a way to see which answers were wrong that I chose? Because I could only see the result, but not the actual correct or incorrect answers. If there's a way, I wonder if I could see those.
Yeah, I actually agree. I actually wanted to see the ones I got wrong as well.
Yeah, because
All
it
right,
showed the result and it says that I need the lockdown browser to see the test, but it still shows only result even if I try the look-down browser.
Okay, I can't show the whole class. If you want to review, I can tell you how many you got wrong. Let's see, something cool. I will send you a chat message, direct chat message. Tell you which ones you got wrong.
Thank you so much.
And Kiva, you too, all right?
Yes, please.
Thank you all for your patience. It is important that we, we all did, pretty well. So let me just get this out of the way. Okay. So I just want to convey that I guess that if I wanted to list the most missed question, it's probably 50. And I think that one probably confused people more. But other than that, it was a wide range of questions missed. I'm checking the attendance here. Give me a second. Making sure I have everyone. A wall of names that I have to scroll through. All right. Oh, all right. Any more questions about the midterm? Their overall average was good. The high was out of 50, the high was 48. The low was 30, 31. So it wasn't terribly bad, but all right. Let's move on. If there's not any questions, if you have any concerns, etc., please contact me via Canvas message and we can address your office hours. I do have office hours in case you haven't or didn't remember right before class. I'm usually here an hour before. You can use those as office hours. So, all right. A reminder, the module 10 activities are, it'll say that it's late, but don't worry about late deductions. I'm keeping it open until Wednesday at midnight. That includes the quiz. But there's no retakes on the quizzes. That's pretty much a standard for quizzes, but the assignment and the quiz will remain open till Wednesday at midnight. All right, let's move on to, and this is a combined module, but it's okay. It's not any additional work. DML is another part of this, the SQL language. Basically, it's the manipulation. So you're actually changing parts of your table, or excuse me, you're changing data within your table. So we're going to move into that now. This is DML, data manipulation language. And our objectives: explain the importance of being able to alter the data in the database, construct and execute insert statements, which insert basically single, excuse me, row using a values clause, construct and execute insert statements that use unique values, null values, and date values. Construct and execute insert statements that copy rows from one table to another using the subquery, and we all know about subqueries now. All right, so up to now, you've been learning how to access data in the database, so hence the select statement. So now, it's time to learn how to make changes to data. I mean, I know you've all been waiting for this. And we're now going to teach you how to make changes. So in business, databases are dynamic, more so now than ever, meaning that there's constant changes. I mean, things have to be updated, et cetera, et cetera. So the data is being constantly inserted, updated, and deleted. Think how many times the student's database changes from day to day, year to year. And it is true. I was a DBA both in business and for a university for a time. And that was my job, basically, to manage the database and to manage those changes that needed to occur. As a matter of fact, several times during the day. Unless changes are made, the database will quickly lose its usefulness. Yeah. So we're going to learn all about the data manipulation language, or DML, as you refer to. It's a subset or a sub portion of SQL. All right. Let's start with the insert statement. And yes, this is the way that you're inserting records or rows into a table. You're inserting a new row in a new table, and that's usually the case. And it requires 3 values: the name of the table, the name of the columns in the table to populate, and then the corresponding values for each column. So how can we insert the data below? Our question, how can we do? Well, basically, if you look at this new data, department ID, department name, manager ID, and location ID, how would we insert that into the departments table? And then the lecture says to copy departments. We're not going to create any copy tables because we really don't need to with these database schema instances. So you can ignore that. So here's the syntax that you would use to insert a new department. So this statement explicitly lists each column, as you see: department ID, department name, manager ID, location ID. Those are the 4 columns in this table. So the syntax is insert into, and then your table, and then your columns, and usually this is explicit, and then your values, which is preceded by the values clause. And then 200 is the department number, human resources, department name, or ID, excuse me, but it is a number. And then manager ID is a number, and location ID are numbers, which if you run that, and then within our developer, you will receive the indication of success by 1 row inserted. Woohoo, I know that makes you excited. And if you go back and run a select statement, select star, you see there's an additional row. Now, I do want to mention, and I think I reinforced this a little bit later, explicit means you're listing the column. There's also an implicit way you can remove the columns, but you do have to you do need to have all the values that are required, that the ones that are not null, in that table, or else you get an error. So, and that's called implicit. I think I do address that right now. So another way to insert values is excuse me, using the implicitly add, and basically you remove the column names. It's the same, but you have to be aware that your values have to match the columns that were created that are not null, and that's the precaution. So is it a better method, or is it what's preferred over the other? I guarantee you, at the beginning, when you're inserting values initially, you probably want to do it the explicit way. That way you won't run into any problems. So here's an example of the implicit method to insert data. You notice the syntax does not include column names, table, and then immediately after the table name, you have the values clause, and then the 4 values: department ID, department name, manager ID, and location ID. Right? Does that make sense to everyone? I'm gonna put this over here so I can see the few people that are responding. Or hi Sopico, how you doing? All right. So that's insert. Insert is very, very useful. And remember, you do have a method to check the table to see which columns are absolutely not null, which means that they require a value when you're inserting. And you see here the department ID and the department name require values. With the manager ID, you can actually keep blank. So if you don't provide values in an insert statement for department ID and department name, you'll get a constraint, a integrity constraint error, and you don't want to get those. They're annoying, but that's the reason why. So you can either check basically describe the description of the table, or just add values all the time. But in some instances, like maybe you're updating the database and you don't know who the manager is yet. They haven't assigned a manager, but they want you to create the department. So in that case, you would create the department with an ID and a name, and keep the manager and location ID, blank, and that will run successfully, but you'll have nulls as far as values for manager ID and location ID until you do what we're going to talk about next. All right, so this is just expanding on that describe. Remember the DESC command is just describe, and you're seeing the type, the data type, and if it's not null, and that will give you an indication once again which columns are absolutely required as far as values when you're inserting. And that's a key that will eliminate any headaches. And then the size, there's a size restriction. If you go over the size of the varchar, or go beyond the size of the number, you'll get once again a data size error message, etc. So be aware of that. This is continuing the description. You see that the salary is essentially of the format 8-2, which means 2 is essentially 2 spots on the right side of the decimal. So when you're entering in, you can either leave it blank, which will default to zeros, or add, because it's of the format, this format here, 6 or 8 and 2, even though this doesn't show 8 nines, but that's the format. All right, inserting rows with null values. So the insert statement needs not, specify every column, and I did say that before. If you have columns that accept nulls, the system will actually add nulls, whether it will insert the word null or you get the little dash, that which means null, which means no value is assigned. Remember that. So in some instances, as I said before, you may be inserting a record with not all the values needed initially, because for whatever reason, a business practice or a manager needs to run a report, et cetera, et cetera. So things like that, be aware of. And I know that there's a lot of functions out there and forms that run SQL in the back end or the background where they're updating databases, just very, very quickly without adding all the values in that record. And that's common. So here's an example of inserting a record or rows with null values. If we remember way back in that describing the employees table, let's go back. You see that employee ID, last name, email, hire date, and job ID require values, right? Those 5 columns require values. So if we run this insert into employee ID, first name, last name, phone number, hire date, job ID, salary, and we have 1, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, but we're missing a column here that's required. Who can tell me which column is missing without looking at the answer? So actually, we don't have an email. Email cannot be null. And we don't have that in our insert, or do we? Nope. Employee ID, first name, last name, phone number, hire date, job ID, salary. So we're matching here, but you will receive this error message basically saying that you cannot insert. And yeah, it is actually telling you, student, this is the database, this is the table, this is the schema, this is the table, and this is the column that's missing in the insert. So it's an email. All right, does that make sense? So be aware of that. And this looks valid, but you will get this. And it's a constraint, and we learned about constraints a little bit. We'll learn more later. And this is how you would want to correct that. And basically we add our email with our email value. You see here, we're adding a blank. So we got employee ID, first name, last name, email, phone number, hire date, job ID, salary, employee ID, first name, last name, email, phone number, hire date, job ID, salary. And yes, the phone number, you can add a non-value, and it's just because the date is enclosed in single quotes with no value in it, and the system will actually, you see that it added a null to the phone number, and that's fine. You can add the phone number later, etc. And we will learn how to do that in a little bit. But just remember a couple things. I want to reiterate the number of columns in your insert into portion of your insert statement must match the number of values. That's the one thing that will give you a headache, especially if you have many, many columns. And especially if you're brave enough to do an implicit. And then just remember with the employees table, we know that there has to be at least 5 columns always. And I don't know if I cover this. Generally, if you know that those five columns are employee ID, last name, email, hire date, and was it job ID? I don't remember. Was it job ID or salary? 1, 2, 3. Well, one of those. But all right, it's hire date and job ID. I was right. So What I would suggest, if you're inserting into the employees table, list those 5 columns first. Always, and because they don't have to be in order of how they appear in your table. But we know that those are required. But anyway, it's just a suggestion. You don't have to do it that way. All right. You can insert special values like sysdate or user, which is your user. You saw in that error message that you all have a user, which is student mine is student 01 and your student whatever. So if I was to insert myself, being hired by the company, I could run and insert into employees, first name, last name, email, phone number, hire date, job ID, salary, and I can use sysdate. Remember, sysdate is a system function that will essentially send today's date to your table. And this is used, it is still used quite because it's a valid way to capture today's date. And if I did a select star from that employee ID, you see that I'm at it with, well, not today's date, but I ran this a little bit ago, a month ago, I think. Yeah, today is March 31st, so, and all that information is in the database, and the rest of the columns are indicated by nulls, right? And that's fine. Just remember that. You can insert specific date values. So remember that whole to char with hire date, and you can identify the format. Generally, depending upon the system will read it as our default format, that day, this is day, month, year, that's our default format in the new database. But if you wanted a different format to display, especially within an output, so this is just a reminder, you can use the to char to create that format. You do have to be very careful depending upon what your database is. This is not inserting, this is just running a select statement to indicate if this was on a report, you probably don't want the default format. You want an easily readable, read date format, although you generally would not have a comma there, but after the month. But anyway, the point is that, remember, that's how you would change the format of your date using the to char. So similarly, if we wanted to insert a row with a non-default date, and this happens all the time with how, individuals input data. The system will store the date in default format, but we need to tell or indicate to the system if it's entered this way, then we're going to essentially change or understand that that's the date format being inputted. But it will show when you do a select from the table, the default date, always that this in this format. This can be a little bit confusing, but remember that default date is the one that the system will recognize as a date. Any other particular format, you may want to change it. But most DBAs will say, let's maintain the default date format. If we want to display it differently, we can do it that way. So store it in the data in the default format, display it any way you like using the to char. Does that make sense? Sort of. Because this is the accepted, yeah, it's finally the accepted format. Believe me, before Y2K, it was a big concern that systems won't understand a 2-digit date year, but it is fine now. We're 25 years into the new century, so we won't have to address that until well after I'm gone. Maybe some of you will last to the 22nd century, but no, I'll be gone. All right. A second example, and this is all about date, if we wanted time and things like that. Once again, it's primarily focusing on what we need to display rather than what we're inserting. And that's, so just remember, this is highlighting kind of the differences. We're only inserting it, recognizing whatever input we're dealing with. But in the database, it will show the default format, and then we can output it whatever way we'd like. And generally, the input, no matter how the data is inserted, the system will recognize it to the whatever seconds, amount of seconds, because it's an epoch time, which is just this big long number. And we won't get into that. It's just that you can differentiate or extrapolate, all kinds of things from the date. But I don't want to overcomplicate it. Just remember, if you're inserting, I would generally stick with the default format, and then the system can handle anything after that, unless you want it specifically to a certain amount of time, et cetera, et cetera. But in my experience, we didn't have to worry about that, or maybe we need to worry about that now. The exact time that someone was hired, I don't think so. Maybe they go to court or something and have to deal with that. All right. Any questions about that? Okay. Second check of the attendance. See, a couple people have joined us. We don't want to pause again. Okay. So moving right along. So we can use a subquery, the little commands that we just learned here, to insert, within the insert to add, let's say multiple rows or to copy a certain amount of rows from one table into another. So generally, you would think, wow, we have to write and execute 100 separate if we wanted to insert several rows, and well, unless they're all single records. But in this case, you can use a subquery to copy a certain amount of data from one table to the next. And yes, it's if you didn't do it that way, unless you had to. But I'll say that in my experience, even if you have, like a form, someone's running a form, and student registration, for example, when you fill out those forms, it's actually running a query in the back end in batch. And it's very similar to what we're going to talk about now. So it has, and I'm not going to talk about views or temporary tables, anything like that, but that's essentially how it's created, because basically there's some routines running to check the data. There's some constraints to check to make sure you enter a correctly formatted email or phone number, et cetera, all of that. All right, so what I'm leading to, so let's say we create a new table and it's called sales reps. And this is going to be populated from our employees table. So in the where clause, we're selecting those employees that have the job IDs like, and we're using the like command, and we're going to use reps. So you see this example and insert into sales rep. That's our new table. We already created it, so assume that. And it has ID, name, salary, commission percentage. And then after that, we use a subquery, select employee ID, last name. Notice the subquery is not surrounded by parentheses, and that is the correct format. So selecting all of these from employee, so it's a pairwise, or it matches column for column. Employee ID, last name, name, salary, commission percentage from employees where job ID like rep. So if you ran this, well, you have to create the table first. In our example, there are other database management systems where you can actually do both at the same time. But in our example, we've already created the sales reps table. And if we ran that, then it would copy those employees and insert them as records with these 4 columns into the new sales rep table. So remember, if you're running something like that, the columns have to match. explicitly. You can't, and well, when we created this sales rep table, I mean, I know this is kind of a general or generic example. We're assuming that all of these particular columns are not null. So it does require that we have data for each of the columns. So just make sure it matches, make sure your columns are in parentheses, matches the columns in your subquery, and then you will be fine. So if we wanted to copy all the data from the employees table to the sales rep table, all those columns, all, well, what do we have, 8 or 9 columns, depending upon what your schema, we can run a query like this, but be very careful when you run queries like this, because it's essentially you're creating a copy of the table. Maybe we don't want that. We're going to call this sales reps. There's really no reason for us to copy all of the data, but it will copy all of the data from the employees table. And then you would have to go in and delete the people that you don't want. So generally this way is a better way to run that example. All right. So now we've learned to insert DML statement to insert records into our table. So it is important to understand how to alter a table because it's very dynamic. Insert, make sure you can either do explicit insert, listing the columns, or implicit, leaving out the columns, but making sure you're matching all of those rows that are not null. And then finally, we ran an insert. If you're copying several rows from one table into a new table, usually that's the case. I've done that many, many times. You can run that using a subquery as a part of your insert statement. All right. We're going to charge right ahead and look at updating column values and deleting rows. And this is kind of the second part. We've learned how to insert, and we've learned how to insert required data. What do we do if we need to update that record with additional data? Well, that's when the update, hence, I mean, that's pretty straight. Or if we need to update, we can run the update statement. And if we need to delete records, which is both of these, you have to be very careful. And I always tell my little story, which is true. I was working for a university where there's certain amount of employees were getting a time in service raise, and we had to manually, we got a list of employees and we had to manually update their whether it was HR, I don't remember, manually update their salary in the table. Well, I forgot to add a where clause, and you may be thinking about what happened. Everyone got a raise, whether they're working there a month or 10 years. Everyone got the same amount of raise, and of course, no one said anything. And I got contacted by a department head that says, "We have very happy employees now. What did you do?" And so I just ran the query, and I went back and I looked, and I'm like, "Oh no!" So when you're running these queries, especially update and delete, make sure you know the absolute condition, and that usually means that you're going to run them with a where clause. I didn't run into an issue where I deleted everyone, although it is pretty impossible to delete records from a database completely. All the systems have redundancies, and we'll talk about that as well. I did mention constraints. You have to be very careful about deleting things in databases because there's what we call integrity constraints. I don't know if you remember, we have parent and secondary tables because we have primary key, foreign key relationships, and you can't just simply delete these without accounting for those relationships, and we'll talk about that. All right. And finally, there's a for update clause, and there's a reason why that particular clause is important, because it will help you to eliminate, integrity, violating some integrity constraints, etc. All right, so wouldn't it be wonderful? I know you love it when you start a sentence like that. Would it be a wonderful world? And I never start sentences like that. I guess I'm too old and senile. I feel like singing, but I'm not going to sing, so don't ask me to. So once you got something done, it never needed to be changed or redone. Yes, it would make it a wonderful world. So your bed would stay made, your clothes would stay clean. Who came up with this stuff? Anyway, and you'll always be getting passing grades. We all know the world is not that vanilla, not that rose color. But so unfortunately, in databases, as in life, there's nothing permanent except change, and that is the worst and overused cliche of all time. But it is true. It is still true. So updating, inserting, deleting, and managing data is a DBA's, and it truly is. I mean, managing data and managing the mistakes that are made by others who think they're managing data. I think that was primarily what I used to do. So we're actually going to learn basically the bulk of what a DBA does. And this is, they call it managing data, but it's clearing up mistakes, because I made a couple big ones in my day. So, all right. So the update statement, let me introduce you to that. And this is basically used to modify existing rows. Update requires 4 values: the name of the table, the name of the columns whose values will be modified, a new value for each of the columns being modified, a condition that identifies which rows in the table will be modified. That's very important, the condition. Yes, remember that. The new value for a column can be the result of a single rule subquery. Yeah. So yes, you can use subquery for updates. So take a look at this sample here, or this example, excuse me. We're updating employees, update table, set, keyword set, phone number is your column, equal to this new value, 480-223-1234, for employee ID condition. Please don't always check to see that your where clause is in your update or your delete statement. It will lessen the amount of angst that you'll have as far as recovering or redoing or coming back from a mistake. And sometimes, yes, we have redundancies built in. You can just do a rollback. That's the easiest way. That's if you destroy many records. Then, but anyway, I digress. So be very careful with the update statement. Make sure you have the condition, employee ID or ID or whatever. So if you select that, I should have done the before and after, but anyway, if you select that, you see that employee ID, which is Angela Wright, has a new phone number, and you probably guess that happens all the time. People change too many things. I've had the same phone number for 30 years now, so why do you need to change phone numbers? Anyway, I digress. All right. So we can change several columns and or several rows in one update statement. That's a good thing about it. So update your table, set your column, and just separate all of your updates by a comma, just like any other command. So we're updating the phone number and the last name because the individual Angela got married, or maybe I don't know what happened, but now my last name is Jones. So maybe Angela and I are together. Well, she should have taken my line. Anyway, sorry, I'm being distracted. So basically you see that I updated because I was employee 303. I thought that was Angela. Anyway, so now we have the same phone number and the same last name. Why? Oh, I threw in this greater than or equal to. Oh boy. That's why I think I was employee number 350. So now, anyway, you just be very careful how things are upgraded. That's why it's returning 2 values here. 2 rows updated. 2 rows are updated. Or employee ID is 3 on. Oh, greater than. I'm still using the greater than. I'm getting confused by my example. Why did I use greater than or equal to? I don't know, to show you that I'm updating 2 rows at the same time. And this is an example. Be very careful. Be very careful of your condition, your where clause. If you don't want, because I probably didn't want myself to be Dwight Jones, right? Anyway, you can do that. And here's that warning, be very careful with the where clause. If you don't have a where clause, then you're going to essentially name everyone Jones in the company, and everyone's going to think that we're all related, et cetera, et cetera. But don't forget your where clause. I can't say that enough. Because of my experience, and I've seen it happen many, many other times before. You can use a subquery. Subqueries can be useful. You don't necessarily have to use a subquery. Remember that. In some instances, a subquery may not be useful, but based on what your condition is for the update, it could possibly save you some time. And in this case, I'm just updating everyone's salary. This reminds me, everyone gets this big raise. Anyway, yes. So subqueries, as you saw in module 10, in our small database, sometimes it seems a little ridiculous, but you're just learning how to use those particular tools. That's why. So they update several columns, and we saw this. Basically, it's the same as selecting, but you're actually updating. And once again, please be careful whom you're updating, and be very specific about your where clause. So in this example, I'm using two subqueries, and you've seen this before in our update. So update employee, set salary equal to select salary from employees where employee ID is 2. So we're just changing the salary and the job ID of this employee of 205 to what 206 was. So Shelley Higgins and William Getz, they were going to be the account managers. So that's useful, right? You can do that with subqueries because we want them both to be the same, although you can just go in there and update. Yeah. So this is because we don't know, what William Getz's salary is, or Shelley Higgins. We're updating William Getz to Shelley Higgins level. Anyway, there you go. Subqueries within your update statement. Very similar to select, but you're actually changing data. Remember that. Right. All right, so you can actually use correlated. Remember, correlated subqueries, basically, it's correlated, and truly it's based on, whatever the return is, and it's dependent. I guess the key here, and this is very similar to your select, and that's a good rule of thumb. I would suggest that you run a select statement to see your values, and then map out or logically think through what you're trying to update. And do you need a correlated subquery? Here we're altering the table just to provide an example. We just added department name to the employees table. So then we're using a correlated subquery to add that actual those department values to the employees table. So basically we're correlating the department's name from the department table. And it's kind of like a join on the select side, but we're making sure that we're placing the right information. That's why it's correlated. Can you do that a different way? Absolutely. But this is one method to ensure that the data is correct across certain employees. Yes, I know it's overcomplicating it, and that's our job. As DBAs, we make the job seem so difficult that no one can do it. Okay, we don't do that anymore. All right, so that's the update. As you see, you can do a lot with the update query. It is and believe it or not, in our complex world, sophisticated environment, we're looking at the DML is probably, other than the select statement, which is the retrieval statement, those DML statements, insert and update, are still commonly used today behind a lot of the applications. Now we get to the real animal that can create problems, although it's not a big deal anymore because there's several backups and redundancies and things to and ways to retrieve information. But anyway, the delete statement is used to remove data, remove existing records. It requires two values, the name of the table and the condition. Yes, do not ever, 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 ever run a delete statement without some type of where. Please. Because you'll have to rebuild your schema or you get lots of errors. So if we go back, because I added myself to the employees table, and the syntax is delete from table where, and then your condition, in this case, employee ID is 150, and you will receive it one row deleted. So here we know that I'm going to delete myself after I inserted myself in the employees table, and you can run that too. So yes, do not omit the where clause. You're deleting all of the data in the database, and yeah, it can be problematic, sort of. All right, so there are ways that the database was built to ensure that you're not doing something like deleting a whole department. So if we ran this query, delete from employees where department ID, and we're using a subquery, and you can use subqueries in all of these statements, department ID from departments where department name is equal to shipping. Well, you can't simply do that because there is a relationship or integrity constraint defined, because there's a relationship between the departments table, and employees table. So this says that if you try to run this as an integrity constraint violation because of this primary key foreign key. So that's what this means. There is a relationship. Essentially what we're trying to do is delete the whole department from the employees table. Well, that's the protection that you have in the tables that will prevent you from doing that. So, and we will discuss integrity constraints and what it means, but you can kind of get the gist. It's just a way to help you, keep the integrity of the data, hence integrity constraints. So the example below deletes roles of all employees who work for a manager that manages less than 2 employees. Yeah, this was one of the test questions that I had, but so if you read through this, delete from, and we're not going to create employees where the manager ID in, and basically we're defining the managers that manage less than, so we're using our group by manager IDs, having, so all of that you should be aware of. And so, and there's no integrity constraint violated here, but it will delete all of the employees, and that can be useful as a subquery. Because you might not know all the employees that have, all the managers that manage less than 2 employees. So this is just illustrating the use of subqueries in your delete statement. All right, let's talk about integrity constraints, just get a gist of what it means. Integrity constraints was designed to verify or continue the integrity of not have you as a user or DBA, compromise the integrity of the data. The constraints are automatically checked whenever you run a DML statement, and basically it's checking to see if there's parent-child relationships, primary key, foreign key, all of that. This is what we deal with a relational database model. But along with that, we know that the model has to be, or the data the data needs to be updated. So you just have to be very careful with any of the DML. So that's why it's checked. So let's take a look at this, and it's not just delete, but it's update as well. So, and here, this example violates the not null constraint, which is an integrity constraint, because last name has a not null constraint, and an ID 999 does not exist. So the subquery returns a null result, our subquery here. And so if this is returning null, then that's violated and you can't do anything with the update. So hence, and reading through these error messages, I mean, it repeats the query in case you haven't discovered this. And it does give you an indication of what the error is. Remember, student 101 is the user, employees is the table, and there's the column and it even tells you that you're trying to add null to a column that it cannot update to null. So you probably were guessing, what does that mean? But if you read through these, I mean, they kind of make sense. User, table, column. So you can always start there and adjust accordingly. And once again, I do want to remind you of a rule of thumb. And some of you, just reading through what you went through the last module, make sure you can highlight your subquery. Just highlight the select to 999 and just run that in developer. And if you see it returns null, then now you got a problem, right? So make sure you do that, because it would eliminate some of the mistakes that you've all made, and not in the midterm, because you didn't have subqueries in the midterm, but in module 10. So, all right. So in a nutshell, this slide is saying that whenever you have this primary key, foreign key relationship, and in our database and in most relational databases, it is this way. Like with the employees table, you have department ID, and it is as a foreign key relationship to the department ID as a primary key in the departments table. That is a relationship that you can't break. And so if there's certain departments you have to delete, et cetera, you have to abide by that relationship. There's a way around that. I'm going to talk about that a little bit more here. So here's a little test to wake you up a little bit. Which of the following statements will return an error? So please read through this and add your response to the chat, please. And this is my little engagement. Which one? 1, 2, or 3, or all 3, or which one, or ones? Or I'm not saying that they're all right or they're all wrong, but which ones do you think will return an error?
At least the second should be wrong, I think.
Some people says number 2 will return an error. All right. Let's take a look.
I think number 3 would return an error because you're setting a department ID over another one.
Will that return an error though?
Maybe not.
Okay, let's take a look at number 2. Delete. All right. Delete from departments. Where department ID is equal to 10. And what does that say? Integrity constrained, foreign key violated. Show the record. So that one definitely. How about the other 2? Yes or no? So can we run 3? Did someone run that already? Hearing no answer, I guess I'll have to run it. Equal to 10. Where department ID equals 20. We're just shifting individuals from one department to the next. Yep, that one was fine. So everyone that was in department ID 10 is now in department, so that's fine. How about number 1? Is number 1 fine too? No one's answering.
I feel like it seems like it would work.
All right, let's validate it.
Yeah, I like to see that because number one looks good.
Okay. What is that? That'll be equal 15, where ID 100. Yeah, we're putting Mr. King in department. Oh, run it. Oh, let me clear this. Run it again. No. Why is that violating? And I did type it in right. Update employees set department ID equals 15. Employee ID is equal to 100. So why is that violating an integrity constraint? Because we have that relationship, right? Employees. So does everyone see why that is violated? We're able to run this one, just changing the department ID, but not this one. Who can tell me why? Come on, be brave. How do you interpret this error message?
I interpret it as that maybe the employee ID isn't found in
Employee
the
ID isn't
table.
found.
Yeah, in the table,
Isn't that
maybe,
King?
or department. I don't know.
I think that's King, right? That's the top guy. Pretty sure he's employee 100.
Oh yeah, you're probably right. Okay.
So right now he's in department 90. So why can't we change him to department 15? Is there department 15?
That was my next guess. Is that there's not.
Let's see. No. Well, does this tell us there's no department 15 or that there's no employees in department 15? This is a test. Now, do we see a department 15 there?
No.
No. So this constraint is only because there is no department 15. So did you guess that for number one? Yeah, you can't put someone into a department that doesn't exist. All right. All right, so we went over that. So it's both one and two, right? All right, so but we have something that we can use to ensure that we're not going to violate integrity constraints. So when a select statement is issued against a database, no locks are issued. This is something that's pretty common in an Oracle. So most of the time, this is how you want the database to behave, to keep the numbers. So when you do a select statement, you lock down certain rows, even using a select statement to make sure no changes are made before the select is completed. So sometimes, however, you want to make sure no one else is changing that record while you're selecting it. So this is when the for update clause is used. And so as soon as your query is executed, the database will automatically issue exclusive row level locks on all rows returned by your select statement, which will be held until you issue a commit or rollback command. So just ensure that nothing's changing while you're running a select statement. You simply insert or add the for update clause. And that's all we're doing here. We're just selecting these columns and we're using a join and just simply for update after your where. And then remember, order by is always last. And so it just locks it so no one else can do anything or on that table until you issue a commit. But when you close the session, that's the same thing. Your system has an auto commit and an auto release. And there's a timeout too, but we're not going to talk about that. But if you want to ensure that the data is not going to change until you finish, running your whatever your report is, that's what the for update clause is used. Is for. All right. So these 4 rows are locked by the user who ran the select statement until the user issues a commit. And we will cover commit and rollbacks in one of our sections, either today or next week. So, all right, so our key terms in this section: delete, integrity constraint, update, correlated subquery, and your update and delete, and then for update of select. And this is why, I guess the key here, as far as a summary, make sure you have conditions in your update and delete. Don't simply run them. And once again, you have to understand what's in your tables as far as data, etc., before you modify all those fun stuff. Relationships don't violate integrity. Make sure you can read those errors so it makes sense. All right, let's charge ahead. Let's talk about default values, merge, and multi-table inserts. So what we're going to do, we're going to understand when to specify a default value, just like sysdate. Construct and execute a merge statement. Construct and execute DML statements using subqueries. This is just kind of the expanded view of that. And then construct and execute multi-table inserts. So that means multiple tables inserts, because you may need to do that. All right, so up to now, we've been updating tables using a single insert statement. So it's been relatively easy when adding records one at a time. What if your company is very large and utilizes a data warehouse, which is usually millions of records, to store sales records, customer payroll, accounting, and personal data, very common. So in this case, data is probably coming in from multiple sources and being managed by multiple people, which is multiple problems, but no. Managing data one record at a time could be very confusing. And once again, very time consuming. So how do we determine what has been newly inserted or what has been recently changed? Yeah, you have a logbook. No, you pay attention. So we're going to learn the most efficient way, one of the most efficient ways to insert data. You also learn how to retrieve from one single subquery and insert rows into more than one target table. And so as you extend your knowledge, yeah, you'll appreciate, well, effective ways. When I say effective ways, it doesn't mean the only way. Please remember that. Maybe your comfort level is not necessarily truly effective, but it's the way you learn, and that's no problem with that. All right, default. The idea of default values. Each column in a table can have a default value specified for it. So in the event a new row is inserted and no value for the column is assigned, the default value will basically be assigned instead of null, which is important. Using default values allow you to control where and when the default value should apply. The default value can be a literal value, an expression, or a SQL function such as sysdate and user. But the value cannot be the name of another column, which is, that reserved name scenario. The default value must match the data type, and the default can be specified for a column when the table is created or altered. So we learned about DDL or table manipulation. So we see here in our create table, we're creating this new table, my employees, and we're using a date default, which is sysdate, and then a first name, last name. The roles are added to this table, sysdate will automatically be assigned as a hire date, which kind of makes sense. You know, when you add that record, now you know you don't have to actually add the date. Very useful. Explicit defaults can be used in insert and update. So if we know that the hire date is defaulted to the sysdate, although you can use sysdate here too, but we can use default only if default is here. Otherwise, you don't use sysdate. But anyway, we can use default just to add that value. That's an explicit. We can also add the default date implicitly by excluding it in your insert. And basically, we're just adding the first name, last name, and it will default to the default date, which I ran this way back in February. So basically, when you create the table, the system will assume, well, it doesn't assume, it will ensure that that value is always the sysdate for the hire date. So explicit defaults can be used in the insert and update statements. So basically, just like the insert, the update's the same. It said hire date equal to default, which is the sysdate. And there's not really any difference between using default here and sysdate. I mean, as far as, you know, efficiency and ease, but yeah, you may want to do that with more than one records or something like that. Just remember that. All right, so that's default. Remember, default can be several data items. All right, let's talk about the merge. Using the merge statement accomplishes two tasks at the same time. Merge will insert and update simultaneously. Woohoo! All right, wow, how do we do that? So if a value is missing, a new one is inserted. If a value exists but needs to be changed, the merge will update it. So it either inserts a value or updates a value. To perform these kinds of changes to a database, you need to have, yeah, we all have those privileges. And aliases can be used with the merge statement. So the syntax, one row at a time, is read from the source table and compared to the rows in the destination table using the matching conditions. If the matching row exists in the destination table, the source row will use the update for one or more columns. If the matching row does not exist, the source table will insert a new row in the destination table. Values from the source row are used to insert a new row. I better say that right. So you see here the syntax is merge into your destination table using your source table on matching condition. So employee ID or employee ID. When matched, then update. When not matched, then insert. That looks complicated, but here's kind of an example that it came out of the queries, but we're creating this new table, copy of impasse, and that's basically select star from employees where department ID, so everyone in department ID equals 100. So we select that. Oh, excuse me, that should be copy imp as. Let me correct that. Okay. All right, so we're creating this table, copy imp, all right? And that's an as, I should have uppercased that, but, and it's using a subquery, so all employees in department 100 will be added to this table. Okay, All right. We're just creating a copy of the table with one department, which is why I'm selecting it there. And so update this new table, set last name equal to Cotton, where employee ID, so on. We're adding an employee named Cotton and that employee ID. Oh, I didn't do a good job writing this query. Make sure this makes sense. Okay. All right. So merge into copy MC using employees on our condition, employee ID and employee ID. When matched and update last name equal to last name, department ID when not matched, values employee ID, first name, last name. Essentially all of this information we're going to pull from the employees table and push it to the copy imp table. So basically we know the department and the last name, and we just want to copy the rest of this information from the employees table to the copy imp table. And that's what we're doing here. So basically we have this one employee, Cotton, ID 205, and we're going to copy all of it, their information. And that's kind of the gist of how the merge into works. I think I was going to run this, but essentially, if you have, I know there's not really a clean scenario to represent this unless we run. If you have a specific record, and we know that the employees table, we have this information like last name and employee ID. If it exists, and we're saying that we can copy everything else needed in this table, which is going to have all these columns, right? And because we're using a subquery to create the copy of the table, which, by the way, you can do that here, if that makes sense. And we went over this before. Basically, in Oracle, you don't have to create the table. You can actually create a dynamic copy by using a subquery, as long as there's not a conflict and you haven't defined the table anywhere else. So yes, if you want to run this, I'm not going to run it now because we're running a little bit late. We have another section. All right, so that was kind of my representation of an example to give you something to run. Well, let's take a look at this example. Employee rows 100, 103 have matching rows in the copy imp table. So the matching copy imp rows were updated. Employee 104, 142 had no matching rows, so we inserted. So basically, and this is the whole idea of using merge. Remember, merge will do the update, the insert or update based on the data, in our new table or an existing table. So if you take a look at this, here's our source table, employees, here's our copy table, and this, we're updating specific information on these three employees, King, Hanold, and Davies, in our copy table. So yes, in this example, it's pretty basic because of our small database. But if you can imagine, having millions of records, et cetera, it does make a difference. You don't have to run several queries. You can run one single and run the update or the insert update all at the same time. That's the whole purpose. All right, multi-table inserts are used when the same source data should be inserted into more than one target tables. This functionality is useful when you're working in data. It's basically data warehouse, large. And whenever I say data warehouse, that's a large database, millions of records, millions of tables even. So you'll hear more and more about data warehouses, especially in industry if you're going to work even the smaller companies are maybe tapped into a data warehouse somewhere. So imagine how many rows of data your telephone provider, yes. Think about Verizon or AT&T or T-Mobile. They have millions of customers. So, and they have so many different scenarios, et cetera, et cetera. So it can be mind-boggling. Although I can tell you now, many of these companies, they're not running simple SQL. They're running several embedded programming languages, and they're doing a lot more than what you're running here. So is this applicable? Well, to a certain degree, yes. Something that you can learn. Its applicability comes when, if you look at some of that functionality, and if you flush it out right at the core level, you'll see some recognizable SQL, believe it or not. So what I'm speaking to here, basically the difference between all and when the data is copied, when it's not copied. So you use all and when, first and when, things like that, specific commands that are used in a multi-table insert. Also, there's the else clause, and you can kind of wrap your head around. We're not going to go into this in a lot of detail because we don't really have the opportunity to create these multi-table inserts. But the whole reasoning behind this, if you're inserting data in multiple tables, it is possible to do that. So let's just take a look at the syntax here. So the insert statement is as follows: insert all into clause, values clause, subquery. So if you look at the actual example, insert all into my employees is just a copy of the employees table, values, hire date, first name, last name, into copy my employees, values, hire date, first name, last name, select hire date, first name, last name from employees. So now you're creating two copies of the employees table from the employees table by running an insert all. And it will insert all the values. Now, there's certain things that you have to consider. There's required fields, hire date, last name, employee ID. But basically, if you're inserting all, it's going to flush out these particular columns within these copies. It can be a little bit confusing depending on what your scenario is, but you can run something like this and not have to worry about certain requirements as far as constraints and not null fields, which you can essentially, I guess, detail specific, data required. Yes, is this more complicated than it has to be? Yes. And it really depends upon what your scenario is. And can you accomplish this in other ways? Yes. But this requires some level of intuition to figure out, is this useful to walk through? Just remember, just key here in that example, the multi-table insert will retrieve the rows from the select statement and insert the rows into both the tables. And that's the key here, the multi-table insert. Insert all requires a select statement in order to run. So we can, however, use the dummy table dual to perform So I would check the multi-table inserts that are part of the practices so that you understand it. Here's one that I put together. And basically I'm pulling out specific employees insert into a copy of the employees, employee ID, first name, last name, email, phone number, hire date, job ID, salary, values. And these are the particular values into that copy of the employees. And then I'm basically using the dual table to copy this information from the employees table into our copy employees. Okay. And here's another multi-table insert, conditional. Yeah, please read through this. And this is a little bit different But there's into all calls, when called format. And this is not associated with one of our tables, and yeah. But this gives you an idea of how you can structure a multi-table insert. And all you're doing here is inserting values into the whole multi-table insert. So I would suggest if that was very confusing, and I buzzed right through that because we have one more. I think we have one more. So default merge and multi-table inserts, all first and else. Oh, we don't. But what I would suggest, since I really flew through that, take a look at I think I do have a video on multi-table inserts. To be frank, I mean, it's one of those things that may not be useful for you. But it is an aspect that you probably want to try and grasp. I don't think I have multi-table inserts on the final, so you can stop panicking about that. All right, sorry about that. I really buzzed through that, but I know this lecture is going long and I want to get into what's required for the week. Don't forget, if those of you that haven't completed module 10, please, oops, shouldn't show you that. How did that come up? All right, so module 10, you have the assignment and the quiz. Please complete that by Wednesday, April 2nd. Yes, it'll say late, but don't worry about late. And then our module 11-12, we just went through our DML. I will post a lecture here shortly, so please don't panic. I have to double check to make sure there's not a lot of nuances in it, as was pointed out to me before. So that's why I'm going to hold off on posting that until, where's everyone? I finished checking it in detail. There is an extra credit opportunity. I know I like to provide this after midterm, and it's just extra credit points. It is a graded quiz. It's 23 extra points. Now I'm not going to preview it for you. If you're wanting to do that, go ahead and go into that extra credit opportunity quiz. It may or may not be based on, no, I think it is based on DML. So you want extra credit, do that. There's nothing wrong with extra credit. I have some of the differentiated languages in SQL. I have DDL, and then DML, and then DCL. Just so you can see what the database commands are. Just to give you a resource to reference. And then there's pretty good videos, once again, updating, DML, deleting. There's one on multi-table inserts. It's one that I'm linking to through Oracle to a resource. So if you really want to, go through multi-table to better understand it, please read through that resource, and it's linked in this list of videos right underneath. I always bust through that because I personally did not like multi-table inserts. It was more confusing than useful, but maybe that's just my problem. All right, let's get through this. And then you have your practice queries. I have everything in there for you to practice. As far as DML, insert, update, delete, several in there. And yes, it is okay. Most of them, you can run them and it will add things and update things. And remember, if you're really leery about what you're doing to your database, is not a problem. As you all have seen, you can always go back to that original query and return it to the way it was, but it's not a big deal. We're not I'm not checking the validity of your data as long as you have data. So please don't be afraid to run DML statements on your database. I hope that makes sense. Yeah, as long as you don't delete the whole table, which you can't. But even if you do that, I mean, you have that original query, you can always run that. So there's practice queries and the practice exercises, always useful. And as you see, even though this is 11-12, they're all listed under module 12 or section 12, excuse me, or topic 12. Insert, excuse me. Update, practice and solutions, and then everything else. Update deleting, and then find a way. My system's slow, haven't been running. And then default values, merge, and multi-table inserts. All right. Always good to go through these. Hopefully you have realized that if you go through these, it'll help you with the assignment. And assignment is the normal assignment. We have 6 little challenges in here. Most of them are just pretty straightforward. Just adding things to your updating. You get Homer Simpson in your table. I know that's going to at least make you smile or something, but yeah. Now that the whole company is going to, yeah. Because now Homer works for you. And then the quiz. All right. And that's all that's due for this week. Insert, DML insert, update, delete, and default values and merge. All right. Phew. Okay, that's the next section. So let's go back. Okay, let me stop sharing. All right. Any questions or concerns about this week? Okay, once again, make sure you finish module 10. That's a subquery section from last week. And then on to module 11-12 as we continue. We're coming down the wire in this class. I hope you're all still okay. Not ready to bolt. Now you can't now anyway, it's too late. You might as well stick it out to the end. Right? All right.
Very true. Yep.
Yes.
Absolutely.
Absolutely. There's no reason to not finish strong. So, all right. So as usual, if you have any questions or concerns, please send me a message. Otherwise, yeah, no more big tests until at least for 3 or 4 weeks. You do have a, well, well, I hate to say this, you do have a final project, but don't worry about that. I mean, I give you everything you need to complete that without any issues. And then a final exam, but don't begin thinking about that. But we do have quite a lot to go over the next 3 weeks, 3 or 4 weeks. So hang on to the reins, etc., as it said, but we'll be okay. You're all still doing good, and please continue that trend. No one fall off. You make it to the end. You go, phew, got that out of the way. All right, have a good evening, everyone. I will see you all next week.
Thank you, Professor.
You're welcome.
Thank you.
Thank you.
Thank you.